All right, starting with problem number 1 for our day 2 review. We're going to start by distributing and then combining like terms. 3x times 11x to the power of 4 will give us 33x to the power of 5. 3x times negative 5x squared will give us negative 15x cubed. 3x times negative 3 will give us negative 9x. Negative 4x times 10x4 will give us negative 40x5. And negative 4x times negative 1 will give us plus 4x. So now our goal is to combine like terms. I have 33x to the 5th and negative 40x to the 5th. And those are the only two like terms I have. So I'm going to start by adding those. That will give me negative 7x to the power of 5. And then I'm just going to continue this into standard form. All right, then I'll have negative 15x to the power of 3. And I actually lied to you. We do have like terms. Negative 9x plus 4x will give us negative 5x. So in our standard form, that is what we should get. Negative 7x to the power of 5, negative 15x to the power of 3, and negative 5x. So minus 15x cubed minus 5x. Number 2, we are going to classify our numbers by their name. So we have monomial, binomial, trinomial, and then the degree. So our first problem, I have 9x squared minus 8x plus 3. Those cannot be combined. So this is going to be a trinomial. And the degree is 2 because that is the largest exponent on one term. All right, so we have 3h to the power of 6 minus 4f cubed g h cubed. Okay, so that is a binomial because we have two numbers. And the degree is for one term. So I can see that this term in the back has a larger degree because I have a 3. G to the power of 1 makes 4, and then g to the power of 3 makes 7. So the degree is 7. So we add up all of the exponents on one term again. So I'm not adding it to the 6. I'm just looking at the largest exponent term. Last one, I only have one number. That makes for a monomial. And there are no variables here. So the exponent is going to be 0, or the degree would be 0. All right. Problem number 3, we're going to start by multiplying our polynomials. I should have a times 3a to the power of 4 will give me 3a to the power of 5. A times 9a will give us 9a squared. And then a times negative 2 will give us negative 2a. Moving on to negative 4 times 3a4 will give us negative 12a4. Negative 4 times 9a will give us negative 36a. And then lastly, we have negative 4 times negative 2 to give us plus 8. So let's see, do we have any like terms here? I have negative 2a and negative 36a. And I think those are my only like terms. Let's see, I have 5, 2, 4, and then 8. So yep. Let's start with the largest exponent first. So we're going to have 3a to the power of 5. Then we'll move on to negative 12a to the power of 4. And then we have plus 9a squared. All right, negative 2 and negative 36 will make negative 38a. And we have plus 8 at the end. So we put it in standard form, which is exponents from the greatest to the least. Okay, I see a lot of us have trouble with problems like these. It's asking what's being added to 2h squared plus 3h minus 7 to get the result of 5h squared minus h minus 17. So what we're really looking for is just breaking it up piece by piece. From 2h squared to 5h squared, what do I add? 3h squared, right? 2 plus 3 gives us the 5. From 3h to negative h, obviously I subtracted. So 3 minus what gives us negative 1? 3 minus 4. From negative 7 to negative 17, what do you subtract? Negative 10, right? So we should have 3h squared minus 4h minus 10. If I added those two together, I would get 5h squared minus h minus 17. Again, what must be added to 5c squared minus 12c to get the result of 3c squared plus 3c minus 9. So obviously I had to subtract to go from 5 to 2, or I'm sorry, from 5 to 3. So they must have subtracted 2c squared. From negative 12 to positive 3, they must have added 15. And since that negative 9 just got tacked on the end, I'm just going to say that they also subtracted that. All right, to find the perimeter of the rectangle below, I could add up all the sides, or I could write an equation that multiplies each side by 2 and add them. So I'm going to do that first. 2 times 5x cubed minus 1 plus 2 times 8x squared plus 3x. So I'll multiply each side by 2 first. So I'll get 10x cubed minus 2 plus 16x squared plus 6x. And I would combine like terms if I could. In this case, I really can't. So I'm just going to put it in standard form. And x to the power of 3 plus 16x to the power of 2 plus 6x minus 2. There we go. All right, we are going to factor completely. Okay, I can see here that all of these are divisible by 5x. So I'm always going to try to start by taking a GCF out if I can. In this case, we can, right? So I'm going to take out 5x. When I do that, I'm left with x squared plus 6x plus 9. So let's go ahead and put that in our factor box. X squared, we have 9, and we have 6x. This looks like a perfect square trinomial to me. Right, so when I put it in the factor box, 3 times 3 gives us 9. When I multiply across, I get 3x plus 3x, which does equal 6x, so that's perfect. So my one factor is x plus 3. My second factor is x plus 3. And I also have 5x. So I can rewrite this as 5x times x plus 3 squared, or I can write out both the factors. Either way works. They are both equivalent. All right, let's try to factor t squared minus 10t plus 11. So we have t squared, 11, and negative 10t. So we could do t times t. Now, this might be a little tricky here, right? Because our 11 is positive, and 11 is a prime number, so it only has the factors 11 and 1, which would give us negative 11t, because we would have to make them negative to try to get a negative over here, and negative 1t would give us negative 12t, so it really doesn't look like this can be factored. And it's not factorable. So because 11 is a prime number, like I said, it doesn't have any other factors besides 11 and 1, and those will not add to negative 10. All right, we have 2a squared plus 8a minus 10. Remember, we're going to try to GCF something out first, and in this case, I can GCF out a 2. That leaves me with a squared plus 4a minus 5. Let's put that in our factor box. And bring my 2 down so I don't forget it. I have a squared, negative 5, and then 4a. So a squared, we have a times a. And negative 5, again, is something that only has two factors, right? One in itself. So we're going to have 5 and 1. The tricky thing here is, where do I want the negative to be? So I want it to add to a positive 4. So I'm going to make it a positive 5 and a negative 1. That way we get 5a minus a. So our first factor could be a plus 5. And our second factor, a minus 1. So we have 2 times a plus 5 times a minus 1. All right, again, let's start by taking out a GCF. That will leave me with y squared minus 25. And I can see that y squared minus 25 is the difference of two squares, which I can break up into y plus 5 and y minus 5. So my factors are 4 times y plus 5 times y minus 5. Remember, difference of two squares only works when you're taking the difference. It only works if you're subtracting. Okay, we have 2g squared plus 5g minus 7. Let's start by deciding if I can take out a GCF. Is there anything that those numbers share? There is not. So let's go ahead and set up our factor box. We have 2g squared, negative 7, and 5g. So for 2g squared, I know I'm going to have 2g times g. And again, 7 only has two factors, one in itself. We're trying to add to 5g. Kind of looks like 59. All right, so 7, again, only has two factors, one in itself. So I'm thinking if I make this a negative 1 and a positive 7, I get negative 2g plus 7g, which will give me 5. So I have g minus 1 as my first factor, and 2g plus 7 as my second factor. If at first you don't get your factor combinations right, that's okay. Just cross off your factor box, erase it, whatever you want to do, and then just start a new one and try a different combination. All right, it says to factor completely. There isn't a GCF that I can take out of everything in here. So I'm going to start by breaking this up and use my method of factoring by grouping. So I'm going to break it up into two pieces. I'm going to factor those each on their own. So from 5k cubed minus 4k squared, I know that they both have a k squared. So that's what I'm going to take out here. That will leave me with 5k minus 4. In the second half, I have 25k minus 20. All I can take out there is 5. And that again leaves me with 5k minus 4. So because I was able to factor out a 5k minus 4 from both parts, that's my first factor, 5k minus 4. My second factor is what's left on the outside, which is the k squared plus 5. So those are my two factors. All right, in our last problem we are going to, again, factor by grouping. So let's start by taking out 3k from the first portion, and that leaves us with k squared minus 4. And from the second portion, we can take out a positive 5, That also leaves us with k squared minus 4, right, from this part. So my first factor is k squared minus 4. And my second factor is 3k plus 5. Is there anything you see here with this first factor, k squared minus 4? Kind of even pointed it out for you over here, right? That's a dots problem, right? So that is the difference of two squares as well. K squared is a perfect square and not negative 4, but 4 is also a perfect square. So I can break this up into k plus 2 and k minus 2. So I have to keep going on this problem to factor completely. And then I will have 3k plus 5. So my final answer will have 3 factors. K plus 2, k minus 2, 3k plus 5. And that is it for your review. Make sure if you have any questions that you reach out to your teacher via email or hopefully in class. Have a great rest of your day.